Hello, welcome to Math 253, Calculus 3, Cañada College. We are in section 2.5, and here is checkpoint 2.43. They want us to find parametric and symmetric equations for the line passing through the points, and this is the point 1, negative 3, 2, and 5, 5, negative 2, 8. Okay. So let's imagine, and I'm not going to draw it precisely, but let's just imagine these are our points. This is the point 1, negative 3, 2, and this is the point 5, negative 2, 8. And now suppose we're in space somewhere. This is our three-dimensional space. Again, not drawing to scale or not doing anything precise at all. Just kind of imagining what's happening. What we want to do to get the equation of the line is to get from the origin to that point, one of the points. So we need a point. And from that point, we can multiply times we can add t times the direction, and so we need a direction vector that's going to be a vector connecting our 2 points. Really doesn't matter which way it goes, so I'm just going to draw an arrow going that way and need direction. And then what's happening here is the equation that we're going to come up with is going to be a point plus a parameter t times a direction vector. And the direction is a vector. You can think about the point as a vector as well. And what happens is that when t is equal to 0, you'll be at the starting point, whatever this point is. When t is equal to 1, you'll be at the second point. When t is equal to like 1/2, you'll be somewhere between, or any number between 0 and 1, you'll be somewhere in between. When t is equal to 2, you'd be farther along here, and when t is equal to -1, you'd be, going this way. So essentially, you're going to draw a line. Okay, so our first task is to get our direction. Our direction would be essentially the difference between those. So let's do the subtraction. Direction is equal to, let's go 5, negative 2, 8, minus 1, negative 3, 2. And then, and then this is going to give us 5 minus 1. Let's make it into a vector. Negative 2 minus negative 3, so that's going to be negative 2 plus 3, and then 8 minus 2 is 6. Alright, so we'll choose our first point to be our first point. Let's just choose this to be our point, and we have our direction, so let's put it all together. Point 1 minus 3, 2, plus t times the direction, 4, 1, 6. And so this becomes 1 plus 4t, if we do the addition, scalar multiplication, negative 3 plus 1t, and 2 plus 6t. So that essentially is your parametric equations. If we just set the x to be our x values, or x component, 1 plus 4t, set the y to equal to the y component, negative 3 plus t, and then the z is going to be 2 plus 6t. Okay? And to make this into a set of symmetric equations, what we'd like to do is we'd like to solve for solve for the t's, and to do that we're going to subtract and divide. So it's going to be x minus 1 divided by 4. So for the first one, t is equal to x minus 1 divided by 4. For the second one, it's going to be y plus 3 divided by 1, so just be y plus 3. And then the last one would be z minus 2 divided by 6. Okay, and if we just see what those things are all equal to, what the t's are all equal to, those will become our symmetric equations. Okay, I hope that helps.